So this is a scenario that I made up, so the conditions aren't really perfect, but it makes sense of a problem to use. A buyer for a t-shirt shop wants to compare the proportion of t-shirts of each size that are sold to the proportion that were ordered. So they have been ordering 10% smalls, 20% mediums, 40% larges, and 30% extra larges, and they want to make sure that the proportions they are ordering align with the proportion they are selling. So it kind of makes sense of why this would need to be done. The buyer counts the number of t-shirts of each size that are sold in a week. The number of t-shirts sold that week were, so because of this sentence, how does that hurt us slightly? It's not technically random. Now, I can just say I'm not going to generalize my results, because if I sold a different proportion in that week than these, then I need to go back and reconsider buying more. So I don't really need to generalize it, but for the context of what made sense here, it did make sense to change that. The number of t-shirts sold that week were 25 small, 41 medium, 91 large, 68 extra large. The buyer wants to determine whether the proportion of t-shirt sizes are consistent with the proportion of t-shirt sizes ordered. So I'm going to write the pieces I want you to write. Let's start writing state. What would our population be here? And this is kind of weird because I'm not randomly selecting from, but in general, it's definitely talking about what, where? Where? So when I go to let P, so let PI be the proportion of what? It's like I'm breaking it down as categories basically here. Size. So proportion of t-shirts of each size. That's not good. T-shirts of. So the size is what I'm really defining here. Because I've already talked about t-shirts, so I could say the proportion of each size. Now, this one is one where I would not really expect a key, and I think that one is extremely explicit, and anybody who's ever bought a t-shirt before in their lives would be able to understand this. But for the sake of this being like an answer key, I want you to write like I said, if this were an actual problem, I would be fine with not doing a key on something like that. So now, my null hypothesis, what would I write? What is my first category? So, proportion of smalls, we are claiming to be what? Proportion of mediums, we are claiming to be. Proportion of large is claimed to be. And proportion of extra large is claimed to be. So that's our claim. Our alternative, it was given to you. This sentence. Our alternative, what do I write? You literally write that every single time. At least one of the PIs is incorrect. And then we'll just say let alpha equal 0.05. Now, I'm just going to talk through conditions instead of writing them all down because that's not the sake of where I want to spend my time right now. Method would be what? Chi-square goodness and fit test. What would I write for my first condition? What is my first condition? Random. What would I write there? Not random, so I can't generalize my results to the entire population. What's my next condition? We're going to write that one down. So let's look at our calculators. So everybody have your calculator out. So without doing anything at all, pretend like you are going to run a test and go to stat, test. Which button do you click? Stat, test, where would I go? Chi-square GOF. What does it prompt you for? It won't say what? But what is it? It says observer expected and what's like there. So this is prompting you for a list as opposed to last class prompted you for a matrix. So if you ever start to do the wrong thing, when you get here, it should stop you. So now we need to go to lists. So I want to edit my list. So in list 1, what do you think I'm going to type? My observed numbers, which are what? 25, 41, 91, and 68. So you should have this in your list 1. Let's go ahead and try to run it. So stat tests. Going down to GOF test, which is D. What is my degrees of freedom going to be? How many categories did I have? 4. So what's my degrees of freedom? 3. And when you hit calculate, what happens? So when I did a chi-square independence or homogeneity in the calculator, I only had to fill out my matrix for observed, and it filled out my matrix for expected. But that's because it calculates your expected based off of your numbers from your observed. And that is not the case here. So you actually have to calculate your expected by hand. I say by hand. So let's go back into our lists. So I need to put my expected counts in list 2. So what math am I doing to figure out what number goes where I'm highlighted right now? So what do I actually need first? My total. Because I've already got you guys in here, I think it's 225. 5, 10, 100, 60, yeah, 225. So I can actually just type 225 times what there? 0.1. So while I'm highlighted there, I can literally just type 225 times 0.1 and it'll do it for me. And then you can keep going. 225 times 0.2, 225 times 0.4, and 225 times 0.3. I don't think that's very difficult, but if you wanted to, because I'm doing the same math over, and I don't like going out of order. So you can put your probabilities here in list 3. And then when I go to list 2, highlight right here and type in what? 225 times L3. Just so that I don't have to type every single one in. Like, I would rather do that just so that I don't hit the wrong button typing something. But you don't have to. Okay, so either way, I've got my observed in list 1, my expected in list 2. Now I can go back and run the test the way I was trying to. So stat tests, goodness of fit test. I'm telling it where my observed is. I'm telling it where my expected is. I do have to tell it my degrees of freedom, which I think is stupid. It should be able to calculate that. And then calculate. So the very first thing it gives us is our chi-square statistic. The second thing it gives us is what? P-value. It tells us our degrees of freedom again. But then it gives us this weird letters thing at the bottom. If you scroll right, it's going to scroll through different numbers. So that CNTRB is contribution. It is telling you what each of your individual contributions are to the chi-square statistic. So if I'm starting at the very beginning, smalls, observed minus expected squared divided by expected, would give me a value of 0.277 repeating. Mediums, if I scrolled over, would give me this chi-square contribution, and so forth. So the 4 numbers that are down there add up to give me this. So we have to type in our expected, but when we do a goodness of fit, it tells us what each one of the chi-square values is, where it did not do that for a matrix. So if I'm scrolling through these really quick and I say, which one contributed most to the chi-square statistic? What size contributed most to the chi-square statistic? Medium, because it had the highest chi-square contribution. So I do want to make sure that we write this on here. So I'll write this too. Your expected counts when we would get to this place would be just a really quick thing like this. And which was 22.5. And that's all I'm writing for that part. My chi-square, I would need to show work, but I end up getting 0.6481. Which would really be like way over here. I don't care if you shade it different. My degrees of freedom was 3, and my p-value was 0.8853. What kind of p-value is that? Generally. That's a really what p-value? That's a really big p-value, which means that we definitely do not what? We definitely do not reject, because we have very, very, very little to no evidence to say that the original claim is wrong. So basically keep buying the t-shirts the way you are. It looks like everything's good.